In this goal, we are going to look at how matter is recycled through the environment. So Earth contains all the elements and compounds, all that matter that it's ever going to have. It can increase a little bit of the matter that it has through meteors landing on the surface of the Earth, but that's just a small drop in the bucket compared to what the Earth already has. Matter can change appearance and form, but it never disappears. So this is called the law of conservation of mass, or the law of conservation of matter. So for example, if I take a log and I start it on fire, at the end I'm going to have ashes and smoke. And if you look at the mass of my reactants, I end up having 31 kilograms, and this is just an estimation. And on the right hand side, I also have 31 kilograms. So the point is that matter cannot be created. It can't be destroyed. It just changes forms. On Earth, there are biogeochemical cycles. What this means is how matter moves through the air, water, soil, rock, and living organisms on Earth. These biogeochemical cycles can involve physical changes or chemical changes. The point is the matter is recycled through the environment. An example of physical cycling of matter is the water cycle. In the water cycle, we have water that is evaporated from lakes and streams that goes up in the atmosphere. Also, plants have water move through their tissues and it is added to the atmosphere. It's called transpiration. Condensation occurs when these vapor molecules that are gases, they turn into liquids. The wind will transport those clouds that contain that water over a landmass, and then that water will get dumped. This is called precipitation. So again, water's a liquid here. The water will run off the mountain into streams, and then they end up back into lakes. We also see water soaks the ground and that plants can uptake it. And it doesn't show this here, but we can have also animals drink the water, and it can go through living animals. So they drink it and then they can sweat it or they can excrete it. Throughout this whole thing, water remains the same molecule. So water is H2O. It has an oxygen molecule bonded to two hydrogens, and it looks this form all the way through the whole cycle. So whether it is a liquid, whether it is a gas, and I didn't mention that it also can be a solid here. So the precipitation can fall as a solid, as snow. So we have all phases of matter here with the water cycle. And water is just going from one form to the next through one organism, whether it be an animal or a plant, through the atmosphere and through our lakes and streams on the surface of the earth. So an example of the chemical cycling of matter is the carbon cycle. So there is carbon dioxide in the air. It's really just a small percent of our atmosphere. About 80% of our atmosphere is nitrogen, and about 20% is oxygen, and that adds up to 100%. But a small portion of that is carbon dioxide, and also about 1% is argon. So let's look at this carbon cycling through the atmosphere. So we have CO2, so carbon dioxide in the atmosphere, and we have plants that take up the carbon dioxide and they actually make sugars and plant tissues. And this is known as photosynthesis. That plant releases the carbon dioxide through either death of the plant, when organisms will go and decay the plant tissues and put the carbon dioxide back into the atmosphere, and also have waste products that maybe you might want to call fertilizer or soil. Basically, the plant just turns back to the soil, the what was once living tissue into the soil. All right, so that's how plants are a part of the carbon cycle. Again, taking CO2 from the atmosphere and then they'll build their tissues through photosynthesis, and then the CO2 is released back into the atmosphere when the plant dies. Another way that a plant can release its tissues or have that carbon move to something else is to have animals eat the plant. So when animals eat the plant, they take those sugars that the plant created, and it becomes incorporated as part of the animal tissue. So how animals get carbon into their bodies is they eat it. So they'll eat it in the form of food. How does the animal release the carbon? It can release the carbon through respiration. So through the animal breathing out, carbon dioxide is released, and that goes back into the atmosphere. Also, when the animal dies, it can release the carbon back into the soil. So organisms can decay it, and through decay, carbon dioxide is released, and also that carbon is added into the soil. All right, some other things in this picture that we haven't gone over is dead plant and animal matter can become fossils. And so we burned fossil fuels in our automobiles, in our vehicles. And so that dead plant matter and animal matter can be turned into fossil fuels. So it can be turned into coal or turned into oil. Our oil that we gather actually comes from fossilized algae that was super old in the earth. Anyway, so that fossil fuel can be refined into gasoline that we burn in our cars. Here we have a factory that's burning fossil fuels to run the machines, and that CO2 is pumped into the atmosphere. And this picture doesn't show it, but you also can have volcanoes. Maybe I'll draw a little volcano here in the distance. Okay. Volcanoes do release carbon dioxide into the atmosphere. But by far, what releases carbon into our world the most is through these emissions, auto and factory emissions. If you compare what a volcano can release versus what our cars and our factories release, our cars release 60 times the amount of carbon that volcanoes release. So really, a lot of the carbon dioxide that's getting pumped into the atmosphere does come from our emissions for burning fossil fuel. And another picture, another thing that is missing from this is an ocean. So maybe I'll draw my ocean way off here. Okay, so here's beachfront property, and here's my ocean. The ocean is mostly water, so a small percent are dissolved salts, but it's mostly water, and water can absorb carbon dioxide. So that's one more thing that is a part of this. So here's my carbon dioxide molecule here. It has one carbon and two oxygens, and the oxygens are on either side of the carbon. It looks like this. And it can give it up also. Our world being mostly ocean, a lot of our carbon dioxide has been being dissolved in the ocean. And that can be detrimental for ocean life because when carbon dioxide is dissolved into the ocean, it makes it acidic. And a lot of organisms don't respond to acidic environments very well. So you might have a decreased plant growth because the ocean is more acidified and it's more so in certain areas than others. If there's not as many plants growing there, then not as many animals are going to live there. So it really does affect the ecosystem of the ocean. But this is an example of chemical cycling. So your carbon changes forms from CO2 to, in photosynthesis, it changes to sugars. Okay, so from CO2 to sugar, and then it might change from sugar to animal proteins. And then it will break down and form fossil fuels, which are long carbon chains. It can all get turned back into CO2, all of these, as they break down. So it's called a chemical cycling because there's chemical reactions that are occurring. So unlike the water cycle where the water molecule always looks the same, H2O, here we have carbon in various forms. So sugar carbon chains, or carbon found in proteins, or carbon found in fossil fuels, and then burning the fossil fuels back to CO and changing them back to CO2. So this is a chemical process where the carbon is cycled through the atmosphere. Here's a summary of equations, and I just want you to be able to recognize and identify what's going on in each of these equations. You will not be expected to write them, but I do expect you to classify them. So let's look at the first equation. We have sun energy plus CO2 plus water, and then we get a sugar. So this is a sugar molecule, and it can be more complex. It can also be other types of sugars, not always. It is not always C6H12O6, so it can be different things also. And then we have oxygen that's released, so it's a product or a leftover in this case. And let's look at the next one. So in respiration, notice that it's the opposite of photosynthesis. So again, we have our sugar, and it can be something different. So it could be an animal protein. So maybe we have an animal eating another animal, and it will breathe in the oxygen, and then it will undergo respiration, where it takes and breaks down through digestion, and eventually the animal will breathe out the CO2. Plants also respire. And so that's a little bit different concept to think about, but they can actually make sugars, but then they can break those sugars down and release CO2 back into the atmosphere. So that's just something to know, that all living things respire. So, but the majority of the way that plants release carbon back into the atmosphere is just through their tissues either decaying or an animal eating them. All right, so other leftovers here are water, and of course a product is energy, which is the whole point of respiration. So providing energy for the organism. And then in decay, we have bacteria and fungi. They will break down plant or animal tissues, and carbon dioxide is a product. Also, through the decay process, we do get fossilization, where we have, through the decay, we make fossil fuels. So if you want to think about, we're basically making oil that then we're refining and making into gasoline for our automobiles. One more equation, that's combustion. Combustion is the process of burning fossil fuels. And so I just did a very simple combustion equation. I don't have to have just a single carbon. So this is the equation of what might happen when we burn our burners in the lab, because we burn natural gas. Natural gas is methane. This is methane. So CH4. In our automobiles, we use octane. So that would be an 8 carbon chain. But the process is all the same. We have a hydrocarbon, so carbon and hydrogen. Sometimes there's oxygen involved there, but we at least need carbon and hydrogen together. It's burned in oxygen, and we release carbon dioxide and water and a lot of energy. So this could be burning coal, or burning a campfire, or burning methane, like in the lab, or burning gasoline. It all has this same type of formula. So carbon and hydrogen reacting with oxygen, and it's releasing as the only product CO2 and H2O, and then giving energy in some form. So let's define greenhouse gases. So in a greenhouse has glass or plastic that allows light and heat to come through, but then it will trap the heat. And so then the plants are in the greenhouse, they can continue to grow even if it's winter outside. So this is the same with some of the Earth's gases. When the heat comes from the sun through the atmosphere, it penetrates the atmosphere, but the gases in the atmosphere trap the heat. And some gases trap heat better than others. Some of these gases are CO2 and methane. And there's other gases too, but carbon dioxide and methane, they are greenhouse gases. So what they do is when they're in the atmosphere, they help that heat to stay on the surface of the earth. So this contributes to what's called global warming. So both of these molecules have been a concern about global warming. The biggest thing that we have control over is CO2. So obviously, the less fossil fuels we burn, the less CO2 is emitted into the atmosphere. Over the last 100 years, where there have been automobiles, the amount of carbon dioxide in the atmosphere has increased, and that has affected the temperature of the earth. There are other matter cycles, such as nitrogen. Nitrogen in the atmosphere, N2, is triple bonded, so organisms have a hard time uptaking nitrogen into their tissues. Animals can't do it, and even plants can't do it. Only certain nitrogen fixing bacteria can do it that can help a plant uptake this nitrogen. So this is a little symbiosis relationship between the bacteria and a plant that allows the plant to basically fertilize itself. Nitrogen is very important for plants. They need it to grow. So how organisms get it is through decomposition. We have also artificial nitrates are added into the soil. 100 years ago, we were not able to make artificial fertilizers, but now we are able to take nitrogen from the atmosphere to make that fertilizer. It's a very more complicated cycle with nitrogen, but nitrates are important for plants to grow. And basically, the plant decaying adds nitrogen back into the soil, or animals eating the plants that have nitrogen, that gets into the animal tissue, and then when the animal dies, that goes back into the soil. Another geochemical cycle is phosphorus. So phosphorus comes from rock. The rock will uplift and form mountains. With water and erosion, that rock is broken up and the phosphates are dissolved into water. The soil uptakes it. The plants get it from the soil. Animals get it from plants. And then when animals and plants die, then the phosphorus goes back into the soil. And this is a little bit different. It's more of a sedimentary cycle, because notice that it never goes into the atmosphere. So it's strictly going from water to the soil. And then when those animals and plants die, they make more sediment that can then be turned into rock that is then uplifted to form the next mountain.